Okay. Okay, good morning, everyone. Okay, how did the homework go, the practice problems? Any questions before we start? Anyone? Okay, so I will start by asking you some questions from the homework and see what you guys came up with. All right, so the main ideas were the domain and range. And okay, let us remember the domain are all the x value, or the input value, or the x value, such that f of x yields a number. And the range are all the output value, all the output values. In other words, all the f of x, all the f of x for x in the domain. Okay, so that's really the two ideas. Okay, so I will pick up some problems from the homework I've assigned, from the practice problem, and I see what you guys came up with. So unless you have something very specific. So let's see. I pick number 3, for example, and the question is, I have a function, and the question is, find the domain. So f of x equals, sorry, it's f of t in the book, the square root of 25 minus t. And the problem is, find the domain. Okay, who has an idea? How did you guys do it? Okay, who's ready? I mean, you should have done those. Okay, put your answer on the chat or speak up.
I put all real numbers except for the fact that t is greater than or equal to 25.
All real numbers such that t is, I will put it in a pencil, bigger or equal to 25. That's your answer? Okay, how did you get that? What's the missing step here? What do you need? What should be the missing step? What should we look for? What should we solve to be able to get to that? Anyone? Yeah, I usually last time when I've talked, it says something we have to solve for. We have to take all the t, which makes the term. So that's what we need. Positive. Okay. So this means that I need 25 large or equal to t, or t is less or equal to 25. So what's going on? Is this answer correct? Is this correct? Is the answer I was given correct?
Okay, no, I said it wrong. So it's t less than or greater than 25.
Exactly. I don't know. That's what you said. I wrote it wrong. Sorry. Okay. So
I said wrong, my bad.
Okay, no problem. But that's why I want you to solve, because when you solve, you will not have to mistake. I don't want you to guess. I actually really want you to solve. You're trying to find every t that makes the term under the square root positive. The t that makes the term under the square root positive means you have to put the term under the square root positive, that which t's will guarantee that this is positive. Every t less or equal to 25. Okay, so don't shy away from solving those. Don't only try to guess. Okay, I will do 2 problems along, review 2 problems. So number 8b. Okay, and here my f of x is x plus 3 over x plus 2. And again, what is the domain here? So what we have to worry about, what's the domain? All right, who's ready? Okay. What is it we have? What's gonna worry us in this scenario? McKenna? What would be your answer?
I don't have an answer.
I can't hear you, sorry.
I don't have an answer, sorry.
Okay, what do you think bother us? What do you think the value of x that give us an issue here? Which value of x? I cannot input it. If I input it, I get nonsense.
Do you set the denominator to equal to 0?
Right. Every x that makes the denominator 0 is problematic. Every x that makes the denominator equal to 0 is problematic. So I'm going to set the denominator equal to 0, which will give me x equal minus 2. And what's the issue here? If x is minus 2, I input minus 2 in here, I'm going to have 0 in the denominator. It means nonsense. So if I input, okay, minus 2 in here, I will have minus 2 plus 3 over minus 2 plus 2 is 0, which is undefined. That's what's happening. So the domain would be all values of x, such that x is different than minus 2. Everything but minus 2 is allowed. Because if you plug in minus 2, I will have a number which is not defined. All right? Okay, so I will pick one and I'm going to give you 2 minutes to do it. You should have thought about those problems. So 8D. So my function f of x now is the following. The square root of 36 minus x divided by x plus 8. Okay. I will give the whole class a minute to do it, then I'm going to pick one of you and I would like an answer. Get going. Think about it. Which x's, when I plug them here, they give me a problem. There is no output for them. Okay. I would like to lead. Anything. I don't care if you give me a wrong answer. I honestly don't care. Anything you say, we go through it. So who would like to take over? Okay, Madison tells me -8. Be clear. What do you mean -8?
Well, I got all values of x, but x can't equal -8.
Okay, that's a good start because that's a very good start.
I put x plus 8 equals 0.
Uh-huh.
And then I subtracted the 8 and I got -8.
Okay, now you understand why this is a problem?
Yeah, because it can't equal 0. The denominator can't.
Exactly, very good. Okay, you still have a missing piece. So you're halfway. So we have to exclude A. So I'm gonna start writing the domain here, but there is still a piece. All values of x, that's that x is different from -8. Thus you got half of it, but there is another condition. Can you nail the other one? No. But there is a square root.
I'm not sure about that one.
Okay, let's think about it. That's a square root sign, right? What happens when we have a square root? What's under the square root? What do we need it to be?
Would it be 6?
Let's not guess. Let's not guess. Let's think. How do you want this term to be? Let me ask you the following question. If I take x to be, let us say, 40. Okay, I'm just picking a number. Will f of 40 make sense? You answer me.
No,
No, because.
you can't take the square root of a negative number.
Right, because if I put 40, I'll have 36 minus 40, which gonna give me -4. So I'm stuck in here. Even though the denominator makes sense, it's this piece that starts giving me trouble.
So would the answer be x is everything less than or equal to 36?
How would we get that?
Well, you can't have a negative number on the top.
So we
it
need,
has to be less than 36.
so we need this one to be positive. Am I making sense? I need this to be positive. So it means that I solve for x. So it means x should be less than equal to 36. That's how I'm gonna pick up the other piece. So x different from -8 and x less or equal to 36. So that's the piece that Maddie missed. So we need two conditions because there is a square root, so I cannot have negative. So which x's I can put here to give me a number, it has to be less than 36. And it cannot be 8. Okay. So I'll give you one more, then I will move review the range, and then I keep going. So I'll just make up one from the top of my head. So suppose I give you, it's not in the book, I'm going to give you one along the one I did a minute ago. So suppose I pick f of x to be equal, square root of 2x plus 6, for example, divided by x. Okay, and find the domain. All right, again, I'm going to give you a minute to do it, and whatever you give me will be accepted. I said we will go over it together. Okay. Again, who would like to lead? Who would like to tell me anything? Put it on chat if you don't like. All x should be greater than -3. Okay. All right, what did you get that from, Taylor? You're right. X should be greater than -3. Where did you get that from? From this one, 2x plus 6. So that's the term under the square root. I want this to be a positive term. So 2x plus 6 positive. To solve this, I need to isolate my x, so I can subtract x from both sides. So that's give me a minus. And then I divide by the 2, which is a positive number, give me x greater or equal to -3. So that's a condition I need. So I need x bigger or equal to -3. Who can finish the problem? So Taylor gave you most of it. There is still one issue. Taylor, x cannot be equal 0. Exactly, because 0 cannot be the denominator. So I have another issue, which is the denominator. So this is one piece, so x has to be greater than minus, and then I have a denominator. I cannot have 0. So the denominator cannot be 0 as well, because if I put 0 in here, I'm stuck. So the domain is going to be all values of x, such that x bigger than -3, but not only that, x has to be different from 0. Every other input it works, but 0 doesn't work, and everything bigger than -3, less than -3 would not work. So if I plug in -4, I have trouble in here. I cannot input it because the function doesn't yield a number. That's really what the domain is. Okay. All right.
I have a question.
Yes, please go ahead.
When you're solving like the 2x plus 6, how do you know like whether to put the greater than or equal to, or just the greater than sign?
Okay, I'll give you the following scenario and you answer your own question. All right. Suppose I tell you f of x equal 1 over that. Are you with me? What's going to be the domain?
Yes.
What's going to be the domain? I want this term to be positive, right? Can I have this equal to 0 or no? What do I need in this case? I cannot have 2x plus 6 0 because it shows up in the denominator. So in this case, I have to write strictly bigger than 0. I cannot put the equality. The reason is I cannot allow this to be 0 because it's in the denominator. Is this your question, or I am not answering?
Yes, you answered it. Thank you.
Okay, they understand. So here, because 2x plus 6 in the numerator, I allowed equality because square root of 0 is 0. There is no issue with that. If it happened to be in the denominator, and then no, I cannot put equality because I'm not allowed a 0 down in the denominator. So in this case, it's going to be x has to be strictly greater than -3. -3 will not be allowed because if I put -3 here, I will have a 0. All right? Okay, any other questions? Yeah, Taylor, you're right. To switch sign is divided by negative, but here I divided by a positive, so I'm not switching sign. So here, to go from here to here, I divided by 2, which is a positive number. I do not switch sign. So I'm safe in this scenario. Okay. All right. Any other questions about that? Okay. So please review them. Now I will answer questions about the range, and then we're going to move on to the idea of piecewise defined functions. So one of your classmates privately asked me to look at number 8, 11, and 12. So I will look at those. And for this one, I need the graphs in the book. Okay. So the question here is, as I told you last time, for the range are all the f of x, all the output values. The only way we're doing them in this class is actually by graph. So we have the graph of a function and then we find the range. So that's exactly what is really going on. So the question is, Below on the left is the graph of a function f. On the right, the graph of a function g. Determine the domain and range of f. Okay. Determine the domain and range of g. You may assume that the graph of f continues forever in the positive and negative direction, x direction. So they're telling us that you can assume, that's what they are telling us, that it's continues forever, so it never stops. Okay, that's what they want us to assume. And you may assume that the graph of g continues in the positive x direction and becomes more and more negative near the y-axis. So this is gonna go like this and keep going. So that's really what they want us to do. Question number 1, for the first function, what's the domain? And then what's the range? All right, who would like to answer the question? What's the domain? It means, according to them, they will allow the graph to keep going. So what are the input that will actually give me an output? That's really the domain. Or real number, is she correct? Everything. You give me a number, all real number. Absolutely correct. If you give me any number according to them, because they extended it forever, whatever number is, I have the output. What is the range? It means what are the output values? Do you guys see the picture? It's in the book. So is -5 an output value? It means, can you give me an input where the output is -5? Yes or no? Please, we have to move on. Is -5 in the range? Okay, I want other students to answer, not only one. Aiden, what do you think? First, you understand my question?
Yeah, what the range is.
Yeah, we're looking for the range. What do you think the range is going to be? What are all the output values possible?
Oh, -4 to +4.
-4 to +4, absolutely correct. -5 is not, because there is nothing that will give me -5. No input will give me -5. Okay, so it's -4 all the way to 4. All of that, everything here.
Question too.
What?
They always mix it up. Do the brackets mean they are part of it or they aren't?
Yes. Bracket means included.
So so that would pertain to like the greater than or equal to
Exactly,
thing?
absolutely correct. Yes. So I will write it in notation. It means all y values such that y less or equal to 4, larger, that's what it means. Okay, bracket, it means the 4 and the -4 are included in the range. All right, now G. What's the domain? And what's the range? According to the picture. Please hurry up. Who would like to? What are the input values to be allowed? Okay, I'm going to pick one if nobody is going to answer. Daniel?
I was going to guess 0 to +infinity.
For the domain or the range?
For the domain.
Okay, is 0 included? According to the picture.
Yeah.
It means if x is equal to 0, is there an output for it? Okay, the picture is a little bit vague. The answer is no, because the way the picture looks is that the graph continues near 0, but it never crosses the y-axis. So it never crosses the y-axis. That's how the picture looks. So domain is going to be everything up to 0. I have open bracket. It means 0 not included. And what's the range? What are the output value?
Would it be 0 to negative infinity?
The idea is correct, but we don't say 0 to minus infinity. What do we say? From minus infinity.
Oh, negative infinity.
Absolutely, it's crucial. The notation is crucial. Okay, so we put kind of the smallest to the biggest. That's how we write an interval. So it means all y values such that y is strictly negative. 0 is not included. So every negative number is in the range. Every negative number is in output. Every negative number is in output. Okay. All right, I will do one more, and then I will urge you to. Okay. I will urge you guys to go over them. Anyway, you're going to have a quiz next time, so you better study this stuff. All right, I will look at number 11, and I will do one of them. You guys do the other one. The question is the same. That's the graph. What you see is what you get. We're not extending anyway. Actually, let me do this one. I'll do that. And the question is, what's the domain and what's the range? Okay, look at the picture carefully. That's an open circle here. Okay, so what's the domain, what's the range? I give you, I don't know, you don't need more than 30 seconds for that. Put your answer on chat also, if you find them, because it helps me to figure out what you're thinking. Isabel, any idea? Are you with me? Isabel, are you with me?
Yeah.
Okay, what do you think the domain is? What are all the input, all the x value for which there is an f of x?
I don't know.
So if I tell you what is f of minus 4, is there an output for that?
No.
No. If I tell you f of minus 3, is there an output? What's f of minus 3 according to the picture? That's minus 3. What's f of minus 3? Anybody else, please? Just stick around. 0, because f of minus 3 is 0. What is f of 2 according to this picture? Okay, I can just go down here. This seems to be minus 4. What about 5? Is there even 4? Is there an output for 4? Yes or no? This is 4. I go down, there is no output. The graph, this does not hit this line. So what's going to be the domain? Madison, what do you think the domain is going to be?
Would it be like -3 to 3?
Yeah, do you think 3 is included in the domain?
Oh no.
No. So we're gonna what we're gonna do here? The bracket gonna look how?
No bracket.
Parenthesis.
Yeah.
No bracket, exactly. But we put parentheses. We just put nothing. Exactly. 3 is not in the domain because, as we realize the picture, that's open. It means this is not included in the domain. Okay. The range. What are the output value? Anybody beside Madison would like to answer me? Don't make me pick.
-6 to 0.
-6 to 0. So I'm going to put -6 here. I'm going to put 0 here. How do you want your bracket to be?
The 6 is in the brackets because it's on the open circle.
So is it bracket or parenthesis?
Oh, parenthesis.
Right. And this is bracket.
Keep mixing.
Okay. All right. So everything between -6. So in words, it means all the y values in words such that y less or equal to 0, strictly larger than -6. Those are the output values. So -7 is not. -6 is not because it's open, and 0 is because -3, f of 0, f of -3 is 0, and that's it. These are the y values. Okay. All right. So today we are going to move to the idea of piecewise defined functions. There are functions which are defined. They don't have a rule, one rule. There are different rules which depend on what the input is. So piecewise defined function. So section 2.3, piecewise defined function. Okay, so we're gonna mainly work with function given by a formula. So most of the functions so far, which are given by the formula, was like this. So suppose I tell you, so you don't have to write this, but I'm reminding you. Suppose I tell you that f of x be equal to x plus 1. Okay, so suppose I give you that. It means you have a rule that you give it an x, that's my rule, and it's gonna spits out the output to x plus 1. Okay, that's one rule for the function. And if I tell you graph this function, graph, which is we're gonna be doing, okay, this is, we should recognize by now, that's a line, and that's crucial. The power here is 1, that's a line. So if you wanna graph this, simply you can take 2 points and graph it. So we're gonna graph it, that's x. This is the output to x plus 1. This is a linear because I'm x plus b. It means the graph is a line, and then I can pick 2 points. So I can put always, I can put 0, for example, and this will give me a 1. And I can put anything else. I don't know, I don't care. I put 1, for example, I would get 2 times 1 plus 1, which is a 3. So this is 1, and this is 3. That's another point, and I graph it. Okay, that will be my function. All right, so that's 1, 3. So this is a function given by only a rule, one rule. Okay. Suppose now, before I hit piecewise, I tell you let f of x equal the following: 2x plus 1. But actually, let me do that now. Let me start the following. So example number 2. Suppose I give you the following: let f of x be equal to. Watch how I'm going to define my function. I'm going to put big bracket here, and I'm going to tell you that my f of x is 3. Take the output 3. If x is less or equal to 5. And 4. The output is 4. If x is strictly bigger than 5. So in this scenario, I'm not giving you one formula for the function. Like here, I gave you f of x equal to x plus 1. That's my rule. In this problem, I'm giving you the output. F of x is the output depend on your input. So I have different formulas depending where my input is. So how do we read this type of function? So suppose I tell you, find the following. So find the following. F of 0. Okay. What is f of 0 in this picture? How are we going to do it? You say, okay, my input is 0. What's going to be my output? I go back here and I ask myself, which condition my input satisfy? Does it satisfy this condition or that condition? The rule depends on my input. So my input is 0. 0 is less than 5. So the rule tells me if your input is less than 5, your output is 3. So f of 0 is equal to 3. That's how we're going to start reading those functions. So let me pick another one, see if you guys got what I want. What is f of 1? Quickly. What is f of 1? What do you do first? Your input is 1. You ask yourself which condition my input satisfy. Is it here or here? So it's equal to 3. Sorry, I didn't see your, all right. What is f of 5? Quickly on the chat. Again, 3, because 5 satisfies this condition. So that's what the piecewise defined function is about. So the rule depends on your input. So now what is f of, I think all of you know what I'm going to ask now. What is f of 6? Now f of 6 is 4. What is f of 5.1? Oh, why not? 5.1 is a number. What's f of 5.1? 4, because 5.1, it satisfies this condition. This is going to be equal to 4. So that's how we're going to, this type of function is called piecewise defined because the formula is really not 1 for every x. The formula depends what x is. Different x's are subject to different formula. Part 2 is graph this function. So I started with an easy function to make graphing also easy in this case. So how do we graph? Remember, when we graph, you're going to put the input value here on the x-axis and the output value here. So these are my f of x. How we are going to graph it? Okay, there are 2 rules, and the rule depends on x. So the way we're going to graph it, first, I'm going to put on my x-axis where things start breaking. It means at 5. That's 5, because up to here, I have 1 rule, and from here to here, I have 1 rule. So now how are we going to graph it? If x is less than 5, it means if I take any input less than 5, my output is 3. So it means my output is constant. It's not changing. So up to, this is 3 right here. If I take anything less than 5, my output is not changing. It's 3. That's my output. Okay, that's how we're going to graph it. Graph gives you the output here. If x equal to 5, my output is 3. I'm going to close my circle fully right there. Okay. Then what happened? When my input is bigger than 5, the output is 4, regardless what my input is. So if this is my 4, and then this is 5, at 4, it's not, sorry, at 5, we're going to open it because, and then after that, 5.1, 5.2, 6, the output is always 4. So the graph is going to consist actually of those 2 pieces. That's the graph of my function. 1 piece, another piece, 1 piece, and then another piece. Okay. All right, now I'm going to take another problem that I'm going to let you work on one. So another problem where I'm going to make one function slightly hard, slightly more difficult. Questions before we proceed. So at 5 here, be very careful what my picture is at 5. It's closed here. It's open here because for x equal to 5, my function takes the value 3. All right, so example number 2 is the following. So I'm going to take my function f of x to be equal to bracket x plus 2. So I changed a tiny bit for x less or equal to 1. So I'm going to put 1 in here. And 4 when x is strictly bigger than 4. Okay, that's my function. So as I said, different rule depending on the input. So I'm going to ask you questions now. So question number 1 is, we have to understand how to read this. What is f of minus 1? What's the output at minus 1? Okay. So how do we answer this question? Okay, please, you can put your answers on chat if you have them. Yeah, exactly. So, but it's not x plus 2. We have to be precise. First, I take my input of -1. I ask myself, what is the formula for -1? We have two formulas. Where is -1 sitting? -1 satisfies this condition. If it satisfies this condition, it means this is the rule that we have for -1. So it's going to be, now you guys are fine, so it's going to follow this rule. So it's -1 plus 2, which is equal to 1. Okay, so the output depends on your input. The formula for the output depends on where your input is. So let us keep playing this game. So suppose now I ask you, what is f of 0 equal to what? So at first, you don't know the rule. You go back here and ask yourself, okay, which condition 0 satisfied? Is it here or here? So what's f of 0? Please on chat, quick, put your answer so I know if you're following me or not. Okay, that's the rule. X plus 2 is the rule. If x plus 2 is the rule, what's going to be the answer? 0 plus 2, which is equal to 2. And that's because here you can ask, because 0 is less than 1. So we follow the first rule. Okay. So 3 more or 4 more along the same line. What is f of 1? And then what is f of 2? 0.1. Sorry, 1.1. And then what is f of 2? Okay, what is f of 1? Okay, what is f of 1? Which rule it will follow? I'm not seeing anything on chat. Anybody? The rule is x plus 2. Right, the rule is x plus 2 because this is 1. It means where is 1 here? That's, you can think of it as the domain. Where is 1? 1 satisfies right here, it's less than 1. So that's the rule that it satisfies. So to find 1 of 1, I have to plug in 1 into that. So it's 1 plus 2, which is equal to 3. So 1 is less than 1 because that's the condition it's satisfied. What's f of 1.1 quickly? Yeah, it's 3. It's absolutely 3 in this case. What's f of 1.1? Again, you take 1.1, ask yourself which condition satisfies. 1.1 is strictly bigger than 1. That's the 4. What is f of 2? 2 satisfies which condition? Strictly bigger than 1 is equal to 4. So that's how we read those type of functions, those piecewise defined functions. Part 2 is graphing. Sketch the graph of f. Okay, now how do we sketch the graph? So as usual, we're gonna take, so it means I need, what I'm sketching the graph, it means I wanna draw all the points with coordinate x, whatever x is, and f of x. So this is my x and my f of x. Okay, now let's see what's going on. The formula is changing. For x less or equal to 1, that's the formula, and for x bigger than 1. So first I'm going to put 1 here because I know that the rule is changed up to here. So up to here I have a rule and then a different rule. So I'm going to rewrite the function in front of us so I don't have to keep pulling the paper out. So that's x plus 2 for x less or equal to 1 and 4 for x bigger than 1. Okay. How do we graph such a thing? Okay, well, listen very carefully. To graph it like this. We say, I'm going to hide the second piece. I said, if x is less than 1, the output is x plus 2. X plus 2 is basically the graph of a line. So what we do is, we sketch the graph of the line x plus 2, but we stop when we hit 1. That's how we're going to graph it. So the way we're going to do it, we say the following. Up to 1, whatever x is, the output's x plus 2. So right here, we're going to graph x plus 2. But we're going to stop the graph at 1 because the output is x plus 2 up to 1. Now, x plus 2 is a line. To sketch it, I need 2 points. Which point will be smart to take? Since I'm going to stop at 1, I'm going to take x values up to 1. So I will never take x equal to 2. So I can take x equal to 0, which is 2. And then I take x equal to 1 because I like to know what's going on at 1. I will get 1 plus 2 equal to 3. And so how we're going to sketch the graph? At 1, that's a 3 right there. And how the graph looks like. X plus 2 is a line. So I sketch the line, but I stop at 1. I don't go any further because the output is y. So this is y equal x plus 2. So I sketch it up to 1 and I stop after that because another rule is taking over right now. Okay, so the way we're going to do it, piece by piece, I sketch the graph of the first piece, but up to 1, and then I stop. Now I'm going to move. What's happening after 1? What happened after 1? What happened after 1 is, so this was 3, the 4 should be here. After 1, if I take any input after 1, 1.1, 1.2, 2, 3, my output is constant. My output is 4. So at 1, I'm going to go up here. I'm going to open my circle here. And now I'm going to sketch the second piece, which is absolutely 4. And this is 4. So that's how the graph would be. I'm going to erase this because this is absolutely wrong. And that's how the graph, those 2 pieces. So from here up to 1, that's the x plus 2. And this is the second piece, y4. So I draw this. I stop at 1. And then I draw this one, which is going to give me that piece. So piece by piece. Okay. All right. Now I'm going to do, I told you, and I hope you guys did it. I don't know. I'm going to do a problem together. So I ask you to print this worksheet because it will be easier for you to work on. And did you guys do it? Did you guys print it? Yes or no? No answers means no. Did you guys try to print it? I've asked you to do that because it will make it easier for us. Okay, anyway, this is my function here. The output is 2x plus 1 when x is less or equal to 3, minus x plus 6 when x is between 3 and 6. So this is my function. And now here's the problem. Evaluate each of the following. F of minus 1, f of 0, f of 1, whatever, f of 3 and f of 5. All right, f of minus 1 equal, I'm going to give you 30 seconds to give me f of minus 1, not more than 30 seconds, because that will be too much time.
Would it be -1?
It will be -1 because which rule we have to use?
The 2x plus 1.
Right, we're going to use this rule because if x equal -1, where is located? Less than 3. So that's the rule that it follows. So it's going to be 2 times -1 plus 1 minus 2 plus 1, which is -1. Okay, f of 0 quickly, and I'm going to pick a student for that. What is f of 0? Olivia? I think I've never picked you. I don't remember. I don't remember who I picked. Olivia.
F of 0 is 1.
Is she right? Which formula you used?
I used the x is, or the 2x plus 1.
Right. Okay, absolutely. Now f of 1, Olivia, quickly.
3.
3, she's right. F of 3, sorry, Olivia, I will stay with you. F of 3.
Uh, 3.
Where did you get that from?
The negative x plus 6.
Read again. Read it again. 3. Which condition that satisfies? The first or the second?
The second one.
No. Because what's written here? Can you read that? This is x less or equal to 3.
Oh, I thought that was a 1.
What? I know. That's all right. Do you understand? So what's f of 3? Olivia?
It would be 7.
It will be 7. Okay, that's better. What is f of 5 now? Olivia?
1.
Because which rule does it satisfy? Where is 5? It's right here. It's between 3 and 6. So 5 is between 3 and 6. So minus 5 plus 6, which is equal to. Okay. All right. So that's how we read it. Now graph it. And usually that's where I have disaster in class. Graph it. How are we going to graph this function? It's 2 pieces. It's 1 rule when x less than 3, 1 rule between 3 and 6. And but after for x bigger than 6, I don't have any rule for you. So we have to stick to that. So this is my 5 here, according to my picture. So my 3 is here. So something happened right there. And my 6 is 3, 4, my 6 is here. So I have one picture here, one piece up to 3. And I have another piece between 3 and 6. Okay. So we're going to have 2 graphs, 2 pieces. That's why it's called piecewise defined function. So let's see how we're going to do that. So this is, I will rewrite my function right there so we can see it. So I don't have like before, pull it up. So it's 2x plus 1. That's the first rule. When x less or equal to 3, that's rule 1. And it is minus x plus 6 when x is between 3 and 6. These are the rules. So to graph this function, I need to do the graph of 2 pieces. I need to do the graph of this one, but I stop the graph at 3. And then I do the graph of this one between 3 and 6. So let us sketch the first one. So I'm going to do that first. X to x plus 1. Okay. First, to be able to graph it, you have to recognize that this is the graph of a line. Because it does have mx plus b. An easy way to sketch a line is 2 points. That's a really easy way. Which point do you want me to pick to graph the line? Which point you want me to pick? I'm listening. I'm going to sketch the graph of this line. Which point do you think will be smart from me to pick? Minus 1. Okay, I can do that. So this will give me 2 times minus 1 plus 1, minus 2 plus 1, minus 2 plus 1, which is going to give me minus 1. So at minus 1, which is going to come here, I am here. So that's my point, one of them. Which other point you want me to take? 0. That's another good point. 0, I get 1. 0, I get 1. Okay. Which other point do you think it's nice to know? Anybody? Remember, the graph has to stop at 3. The graph has to stop at 3. And what I would like to know is, where does it stop? So if I am doing it, I will go to 3 because that's where the first piece is going to stop. I ask myself, what's happening at 3? It's 2 times 3 plus 1, which is 7. This point is nice to know because I want to stop my graph at there. So now I go at 3, I am at 7. And now I draw a line. It has to be a straight line because that's a typical linear function. So by weird chance, I have a ruler. I grab a line, absolute line That's the first piece. Okay, and this point is included because we have equality right there. So that's the first piece of my graph. This one is totally reflected right there. Okay, now I want to finish. To finish, I need to sketch this line. Okay, so now part 2 is I need to sketch the other line. X and minus x plus 6. And I gave you a grid so you guys can sketch it correctly. So which point do you want me to take now to sketch the line? So remember, this is a line because that's linear. This mx plus b, that's a line. Which point do you think are good points? Because you're going to have a line. The slope is negative. The slope is -1. So we know that the line is descending. It's going to fall. And we are going to draw it between 3 and 6. Right here. Okay, which point do you like me to take? Five will do. 5 will do. I will have -5 plus 6. It's equal to 1. So 5, I am at 1. 5, I am at 1. Which other point you like me to take? 5 is good. Which other point you like me to take? So I have 1 point. This is a line. To draw a line, I need 2 points. You guys gave me 1 on this line. I want another one. Come on. Give me another one. 4 will do. Okay, I'm going to go to 4. And this is 4. I will have -4 plus 6, which is equal to 2. So at 4, I am at 2. Okay, now I'm going to draw the line. How can I draw it? Watch very carefully. I want to draw it between 3 and 6. Okay, that's the piece. So I'm going to take and draw it. So, but the question is, I need to connect. So let's see, am I right here? Yeah. Okay. My question is, I'm going to draw this line like that. But I would like to know, because it's everywhere between 3 and 6. What I actually would like to know is what should be the value here? So I know how to connect. And what should be the value? So this is 6. What should be the value here? Okay, what should be the value here? It's open because at 3, the output is obtained here. So what this value would be. So I like to know what's happening at 3, but I will open it so I can have a good graph. At 3, we're going to have -3 plus 6, which is 3. It means this value here is 3, but it's open right there. So it's always nice to know what's happening at the end point, 3 and 6. It's nice to know what happened, though, but you open your circle so you can have a good graph. Otherwise, you're going to have really a bad graph. So when you're drawing those lines, I advise you to know what's going on at 3, what's going on at the end point, so you can have a good graph. So it's going to be open here, a straight line. At 6, it's going to be open right there. And that's already what my graph would look like. Okay, it's 2 pieces, and they cannot overlap. There are 2 separate pieces. And 3, that's what's happening at 3. Now find the domain and the range. What's the domain here? And what's the range? All right, what's the domain? Okay, according to the formula I gave you, according to the graph, what's going to be the domain? I'll go back and pick a student. If nobody's going to answer, I'll pick one. Matt Trimmer, what do you think the domain is going to be? What are the x values? First, are you with me, Matt?
Yeah.
Okay. What do you think going to be the domain? What are the input that yields an output in this picture?
3 and 6, 3, 2, 6.
Why? What about 0? Why it's not in the domain? Is there an output for 0?
Yeah.
Now fix your domain.
So would it actually be -1 to 6?
What about -4? Why -4 is not in your domain? If I give you an input of -4, can you give me an output for it? According to the rule I have. If I put -4 in here, will the rule gives you an output or tells you there is no output? What does the rule tell you? If you pick in -4, -4 is less than 3. So f of -4 is going to be -8 plus 1, which is -7. I'm trying to push you a little bit. What's the domain? Is 6 in the domain? Matt, stay with me. Is 6 in the domain? Not 6, sorry. 7. Is 7 in the domain?
No.
No, because there is nothing. You cannot give me an output. The output is given for x less than 3 and x between 3 and 6. It means as long as you're less than 6, I'm giving you an output. I'm not giving you an output for bigger than 6. So is 8 in the domain?
No.
Is 5 in the domain?
Yes.
Is 3 in the domain?
Yes.
Give me the domain. Is
So would
minus
it,
5? Yes, go ahead.
would it be from both lines is what you're looking for, or just from the second one?
Everything you see. All of it. That's the graph. Everything you see.
So then would it be -infinity to 6?
Yeah. Now we're talking. Is it open or closed at 6?
Open.
Open, because I'm not giving you an output at 6. It's totally open. Okay, so the graph is the whole thing. So this function, which is defined in a weird way, that's its graph right there. All right, what's the range? Matt, stay with me. What are all the output value in here? Means all the y values that correspond to an x. And I will play the same game with you. Is 3 in the range? So that's 3. Can you give me an input? That's the picture. Can you give me an input whose output is 3?
Yeah.
Yeah, because we go back. This one. So it's in the range. Is 5 in the range?
Yes.
Is 7 in the range?
Yes.
Is 8 in the range?
No.
Give me the range.
Would it also be -infinity to 7?
Is 7 included?
Yeah.
Because
It is a closed circle.
what's the input that's giving you an output of 7? What's the input that's giving you an output of 7? So this 7 is coming from which input? It means what should you plug in for x to get an output of 7? You can look at the picture.
3.
3. Don't be afraid. It's coming from 3. So it is in the range. So -infinity 0, and it has to be closed right there. And that's the range. Okay. All right. We're going to do another one, and you guys have to try to work hard with me to get that. And next time, because I'm going to do the opposite. Next time, I will give you the graph. You will have to find the formula. We're going to do backward. Okay, so we have to get at least this piece going. All right, consider the function given by that rule, the one you see. Evaluate each of the following. All right, so again, I'll give you a minute to fill in your answer, and then I will start picking student. Because if you don't volunteer, I will pick. If you volunteer, you guys are fine. So the worksheet is on bright space, so it's if in case you don't see very clearly, but that's it. So it's 2x, x less or equal to 0, a 3x minus 5, and it's a 4. Okay, in a minute, I start asking you questions. Okay. I think you had enough time. We'll get started. F of minus 1. Taylor, are you asking me, are you answering? I don't know. Okay, Taylor, what's f of minus 1? Okay, all right, minus 2. She's right. Minus 1. Which condition satisfied? Minus 1 is less or equal to 0. So the rule for it is this one. So it's 2 times minus 1. This is minus 2 because minus 1 satisfies this condition. That's really what my rule is coming from. What is f of 0? Let me pick J Sean. Sorry if I didn't pronounce your name correctly. J Sean, what's f of 0? Are you with me first? J, are you with me? I don't think so. Okay, all right. So what's f of 0? Okay, McKenna, are you with me?
Yeah, would it be 0?
Yeah, because which rule do you use?
2x.
2x, yeah. Stay with me, McKenna. So it's 2 times 0, it is 0 because 0 is less or equal to 0. There is inequality down here. F of 1, McKenna, stay with me.
-2.
Because which
It-
rule you using?
It's between 0 and 3, so it's 3x minus 5.
Okay, because 1 is between 0 and 3. So that's the rule we're using. F of 3, Daniel. Daniel, f of 3. Daniel, f of 3. You take 3, ask yourself, which condition it satisfies? This one, or that one?
It's gonna be the bottom one.
So what's f of 3?
4.
4. What's f of 4?
4.
4. So that's how we read it. Step 2, I want the graph. Okay, so I'm going to rewrite my function. How many pieces will the graph have? So I'm going to rewrite the function here. It's 2x less than 0, 3x minus 5 between 0 and 3, and 4 for x larger or equal to 3. And I'm going to ask you to sketch the graph. Every function I'm giving you is a line. That's a line, and a line. All right, I want to give you a few minutes to graph it by yourself a little bit. And I know it's hard for me to check you what you're doing. Usually that's what I would do in a face-to-face. But I want to give you the chance to graph it. Okay, and then I will graph it myself and see if you guys got it right. But please be honest and try to graph it. That's how you're going to be able to graph it on your quiz on Tuesday. Remember, we have 3 pieces. We have to graph each one of them But we have to graph it, restrict our graph to where the output work. So as I said, I'll give you a little bit to do it, and then you guys check yourself. Are you doing it right or wrong? Please do it. Okay. Okay, let's start. I'm gonna pick one of you and tell me how did they start by graphing. Okay, let us say Peyton. Okay, what did you do? Peyton, are you with me?
Yeah, I'm with
Okay.
you.
What did you start by doing?
I was a little bit lost, but the first thing I did was x equals 4. Is that right?
Okay,
For the
and
bottom one?
yeah, because that's an easy one, right?
Yeah.
Okay, how did you do that? Let's be very precise. Where did you start X, the last one?
Did you say why did I start at the last one?
Where did you start it?
Oh, I put it at 4 on the x-axis and it just goes.
No, 4 is on the y-axis, because that's the output.
Oh, okay.
That's my fault. That's why I want you to do it, because that's how you're going to do mistakes. And then the output is 4 for which input? Let's read it. The output is 4 when the input is what? Is bigger or equal to 3. So 1, 2, 3. This is 3. That's my input. Did you see where I'm putting it?
Yeah.
And the output is 4 for which input? Only when x is larger than 3. So the way we're going to graph this, every time x is larger than 3, 3 is included, the output is 4. So this will be the picture for the last piece. When I told you where to start, actually that's what I meant. Means you don't draw 4 across the board. This is wrong. The output is 4 only when your input is 3. Before that, your output is not 4. So you only start right there. Am I making any sense?
Yeah.
Okay, so you started from 3. That's x larger or equal to 3. That's when my output is 4. So that's really how we're reading it. So what happened here should be reflected in the graph. Okay?
Okay.
This takes care of which piece in the whole picture? It takes care of that. So this piece is reflected right there. Okay. Now, how I'm going to graph the first piece. So now let me focus on that. Okay, who would like to tell me how they did it? The first piece. First, 2x holds for x equal to 0. So the first piece, if my output is less than 0, so it means right there, the rule is 2x. How do you want me to graph this one? And this is only for x less than 0. How does the graph of 2x is going to look like? First, what we should recognize is output 2x. When you graph it, it means if you take all the points that satisfy y equal to x, those points are going to live on a line. And that's really crucial. So how do you want to graph this? Which values do you think will be important to us? Remember, we're going to stop at 0 because the output is 2x if x is less than 0. So which value do you think will be relevant to us in this problem to sketch the line? Peyton, do you think you would like to stay with me?
You want me to answer this one also?
Yes. Yeah, why not?
Okay. So for this one, it would be, if we work it out like the same way, it would be x is less than or equal to 0 on like the same axis as before, or like on the x-axis, and then we plug in the 2x to find the line, correct?
Which one? Which axis you want? And that's what my question. I want you to pick them in a good way. Which axis do you think you want?
For the 2x?
Yeah, the values here. Yeah.
The x-axis.
But to draw the line, you need 2 points on it. That's my idea. How can I draw the line y equal to x? So if I take the following, forget about this for a split of a second, because I want you all to follow it. Okay, so forget about this problem for a little bit. And I tell you, suppose I tell you, sketch the line, forget about piecewise, sketch the line y equal to x. How would we sketch this line? How we sketch a line? You take 2 points, because if you know 2 points, you have a line. That's one way you can sketch it. Or a point and a slope. But 2 points will do. So if I want to sketch this line, I said, if you give me 2 points, I know what it is. So I can take 0. So this line go through 0, that's the intercept. And any other point. And then I have my line. You can pick it 2, you can pick it -2, -2. And that's what gives me that line. So that's what sketching the line y equal to x. That's a line because it's mx plus b. Sketch it, any 2 point will sketch. What does it mean to sketch? It means if I take a point 1 here, I go up here, this should be 1, 2. Means every point on this now will satisfy this equation. If I take -1 here, that's going to be -2. And if I pick 4 here, this is going to be 8. So that's what this line represents. So sketching this line, it means we take 2 points and we sketch it. Why I'm talking about that here? Y equal to x. It's the same thing. I'm going to sketch the line y equal to x. The difference is I'm going to stop my graph at 0. That's really the difference. So this is going to go. And I'm going to sketch it up to 0 and stop. That's really what's happening in this picture. So I'm sketching the line y equal to x. I stop the graph because I'm only interested in this piece up to 0. And I stop right there. Okay, so when I'm going to sketch y equal to x, okay, I'm going to take 2 points. So I take 0 because, and I take -1. So 0 is included. And -1, I am at -2. I sketch my line. And I stop right here. So this is the line y equal to x. So basically, I take the line y equal to x and I chop it. So I only draw it up to 0.
Okay.
Is it making a little bit better sense for all of you? It's crucial. Now, the last piece, 3x minus 5. It's the same scenario. It's the same scenario. I'm going to sketch the graph of this line, but I want to only sketch it between 0 and 3. That's really what I'm interested in. Okay, so again, I'm gonna stop, go back. I'll probably take you a little bit, a few minutes extra, sorry. But I want you to get that. So y equals 3x minus 5. This is a line. If I tell you sketch it, basically, you should sketch 2 points or point and the slope. But let us focus about 2 points in my problem. You can pick any 2 points. So if I pick 0, for example, will be minus 5. In this scenario, I don't know, I pick 1, but I get minus 2. So minus 5. And at 1, I have minus 2 somewhere in here. So that's the line. That's a line. But in my case, which piece of the line I am interested in? In my scenario, for x between 0 and 3. So in my scenario, I only want the piece between 0 and 3. But now 3, I don't know where it is. So I said, you know, if I had taken 3 here, I would know where to stop. So if it's 3, I will have 9 minus 5, which is 4. So at 3, I should be here. And now the part of the graph I'm interested in, this has to go, is the one between 0 and 3. That's the piece I'm interested in, because that's my output between 0 and 3. This is open because 0 was not, and this is open, 0 but not. That's the piece I want. Is it making any sense to anyone? Okay, so now when I go back here, what I'm going to do, I said, okay, this is a line. The piece I'm interested in is between 0 and 3. So I know it's a line, so I'm going to take 0 and 3, the end point, because I want to know, I know it's a line, but I want to know how is it located. So this is x minus 5, and this is going to give me 3 times 3 minus 5, 9 minus 5, which is 4. And now I go back and sketch it. I say, okay, if x is 0, it's minus 5, but that's open, absolutely open, because strictly positive. And then at 3, it's 4. Now, it should be open because strictly less than 3, but this is already closed because it's a 4 in here. So I'm going to go all the way up here. A straight line, honest to goodness straight line. And that would be the graph. So this piece here is y equal 3x minus 5. So that's really my graph. So this one here, each piece is drawn by itself. This one goes here. This one is going right there. And that's really how my graph will go. Okay, now I have a question. I thought we couldn't do 0 because it's a, yes, you're absolutely correct, Esmeralda. Why do you think I took 0? The reason I took 0, because I want to know where to start. Okay, so I can take 1. I know where it is, but then I want to know what's happening here. I like to know what happened at the end point, so I know where to start and where to end. That's the reason I picked those values, so they guide me. But I opened it. I definitely opened it because it's not included. So I use them as a guideline. How can I draw my line? How can I, what's happening from here to here? Okay. So that's really how we're going to graph those. And so basically I'm graphing. So for example, here I got f of 3 equal to 4. My graph should reflect f of 3 equal to 4. I got, for example, f of 1 equal, and when you guys gave me minus 2, f of 1 here is minus 2 also when I graph it. So the output I get from A should coincide with the output I'm getting straight from the graph. Okay, so sorry for taking a little bit more time. For Tuesday, you're going to have your quiz, and it will cover all about domain range, and everything I did today will be on your quiz. And I will put up a Moodle homework, but I will put it up tonight because I didn't have time to do it. You will have a Moodle homework, and it will be due next Thursday.
Wait, you said you haven't put it up yet?
Yeah, I haven't. No, I did not.
Moodle like a little bit ago and it was there.
What?
There was two things on Moodle, one for sections 1 and 2 and one for sections 3 and 4.
I will make sure I'll get rid of them. Okay, I will put it
I
tonight.
already did the section 1 and 2 one.
You did? Okay.
Yeah. I
That's
didn't.
the bad.
You said you
That's
didn't
the bad
post it yet.
domain and range, right?
Yeah, that's what it was.
Oh, all right. So I will keep it. I
But
will
there's
go
also
over.
a 3 and 4 one.
No, you can't do 3 and 4. Actually, I was playing with it before class to see with what to give
So maybe
you,
that's
honestly, and I seem I kept them on. That's what happened. I was looking at it. I say, okay, what fit the lecture? And I must have kept them on by mistake. So I will put them out clearly tonight.
So don't worry about the 3 and 4 one.
No, because the 3 and 4, the way Moodle work, I can't mix and match, which is problematic for me. The 3 and 4 cover this section and cover the following section. And I don't think I have time to do that prior to next Thursday.
Okay.
Okay, so it's gonna be mainly the assignment you did.
All right.
Right? Okay, any other, the section, the class is dismissed. Anybody who